so this is 7.3 part 2, which is applying what we did in the first part, finding the critical values, and then testing to see if the critical values do give us what we're looking for, either maximums or minimums. So this is applications of optimization of two variable functions. It's very similar to what we did with one variable cases, right? We found absolute values, we tested using the second derivative test. Same things here. We're going to find the critical values and test using the second derivative test for multivariable functions. Involves that D formula. So again, similar, just a little more complex because, we've got two variables in each equation. Alright, so the first one I'm going to kind of walk through all the steps that we'll be doing. So, we're given a weekly profit in dollars if a company makes and produces and sells bookshelf loudspeaker systems. Alright, and it's given by the equation P of X, Y. Right? Find the maximum profit using and verify using the D test that your answer does yield the maximum. Alright, so first thing, find your partial derivatives and make sure you clearly label them. Alright, so that we know it's the derivative with respect to X, right? Because it matters. Derivative with respect to Y. Alright, so simple as I'm looking for P sub X, derivative with respect to X. Alright, so I'm taking the derivative of this function with respect to X, so take the derivative of all the X parts, excuse me. So the negative 0.25x squared comes out negative 0.5x. Next term has no x's in it, so it zeroes out. Then the negative 0.25xy, the derivative with respect to x, is negative 0.25y. 120x gives me 120. And then the rest zeroes out. Now the derivative with respect to y. Alright, so first term there's no y, second term there's a y squared, so derivative, take the decimal times 2, which comes out to be negative 0.75 y. The mixed derivative, negative 0.25 x, and then 100 is the constant. Alright, so there's my two first order derivatives with respect to each variable and labeled clearly, right? That's clearly my derivative with respect to x. That's clearly my derivative with respect to y. Make sure you set them equal to 0. We can only solve for critical values if we set both derivatives equal to 0 and then solve. Right? You have to show that step. It's a key step. Anything you do after that will not be true unless you've set it equal to 0. And so what we'll do is then we'll solve the system. All right. So step 2. Make sure you set it equal to 0, key step. You don't want to lose points for not showing that. And now solve the system using one of the three methods that we talked about in the last sections. Show all work, meaning I want to see how you solved it. And so this is actually a linear case, right? They're both linear. I've got just x terms, y terms, and constants. And so this is a linear case, which means I can set them up in the form ax plus by equals c. And so that's the first thing. Before I can plug them into the matrix, right, I have to have them in the right form. And so that means moving stuff around a little bit. So in the first equation, I've got to move that 120 to the other side, and then it's fine. Alright, so the first equation simplifies the negative 1/2 x minus 1/4 y equals negative 120. Alright. The second equation, I've got to move my 100 over. And then when I rewrite it, I'm going to write it in the right order. X first, then y, and then equal to my negative 100. So the x term first, which is negative 0.25x, then my y term, negative 0.75y, equals my negative 100. If you want to, you could multiply through by a negative, so you don't have to plug the negatives into your calculator because it'd be easy to miss. But it's up to you. Alright, you can leave it. Now we go to the matrix, alright? So when you go to your matrix on your calculator, it's a 2x3 matrix. The first row represents your equation 1, remember x term, y term, constant. Second row represents the second equation, x term, y term. And that should have been 120, not 100. This one's the 100. Double check and make sure I wrote it right. Right, negative 1/2, negative 1/4, negative 120, negative 1/4, negative 0.75, negative 100. And then you go to your calculator, math key, right? You go to the math key, row reduced echelon form. and it'll give you that simple Gauss-Jordan reduced equation. Alright, comes out to, alright, which remember the first term is your x value, the second term is your y value. Alright, so there we've solved the system, and that's the work we want to see. Alright, so again, show all of this so that we know how you solved it. That you just didn't pull the answers out of the air, that you actually plugged it in and solved it correctly like you're supposed to. Showing your work is going to be key. Right, if you don't show this, you'll lose points. Alright, now, so our guess is that when we have x is 208, y is 64, so again, there's my critical point, is 208, 64. And now I want to verify that does give me what I'm looking for. Alright, so we use the d-test and plug your values in and then check the concavity. Alright, so remember the d-test is, I'm going to write it out, the second derivative with respect to x twice times the second derivative with respect to y twice, second partial derivatives, and then the mixed partial derivative squared. Don't forget to square that mixed partial derivative. Alright, now in linear cases, these will always be numbers. Alright, so when it's the linear case, when I take the second derivatives with respect to each variable, these are just going to be numbers. So I'm just going to plug in the numbers. So I'm going to go back up and find my derivatives. And so first I'm going to look here. I'm going to erase that negative 120 so I don't distract me. Take its derivative, so the derivative of the first order derivative with respect to x with respect to x again. And that's just going to leave me with this constant in front of the x term, the negative 1/2. So that goes here, negative 0.5. Alright, now the derivative with respect to y twice. So now I'm going to look at the y part. So again, I'm looking here. Take the derivative of this with respect to y again, so that's just the number in front of the y term, the negative 0.75. Alright, negative 0.75 goes here. Alright, now the mixed derivative, you can find either one. Again, we standardize it by saying we look here, but technically you can look at either one. The same thing comes out of either one. When I take the derivative with respect to y of my first one, I get negative quarter. So negative 0.25. And don't forget that negative 0.25 is squared. Alright, again, because it's the linear case, whenever it's the linear case, and most of our application types will be linear cases, so you can solve with a matrix. These will always come out as single numerical values, which means it's the same concavity over the entire function. There is one peak or one valley. Right? It's kind of like a 3D type of a parabola, right? If a parabola opens up or opens down, well, this is the entire graph opens up or the entire graph opens down, and there's a peak if it's a maximum, and then there's a valley if it's a minimum. Alright, so you simplify that, multiply it out, and see what we get. It should come out positive. Right, it's a small positive, but it is positive 0.3125. And so that all that is a check. Yes, the critical value is an extrema. Right, then we look at the concavity to see which one it is. So the second derivative with respect to x, the one we pull, although technically you could do y. Alright, which was our 0.5, negative 0.5, that was less than 0, so that's telling me it's concave down, cup down shape, and so yes, we found the maximum. Alright, and since it's the only one, it's got to be the absolute, right? Absolute maximum. And so give your answer with units. So what we're looking for is the maximum. So I'll go back and make sure I answer the question. Find the maximum profit, verify. So we did verify, so now all we have to do is find it. Alright, now I know that the maximum profit is at this critical value. And so I take that critical value and I plug it into the original. And my answer will be in dollars, right? Profit was in dollars. I take my profit equation, plug in 208 for x, 64 for y. And so again, just make sure you carefully plug it in. The biggest mistake would be just accidentally mistyping something. That's again what I will do. Double check me. Make sure I didn't lose a negative somewhere or mistype something. When I get the final answer out of this. Alright, so there's it written out. And then the final answer is in dollars. This would be my maximum profit. Alright, so when I type that all out, I get 10,680 is the maximum profit for that problem. Alright, so this is basically what we're doing. Again, these are going to be show your work problems. Alright, so the final answer is important that you get there, but showing all the steps in the work are also what we're looking for. The bulk of the points will actually come from showing your work. Alright, the next problem. We actually had this one earlier when we first introduced multivariable functions. If you go back and look at the 7.1 video, we did this one, we set this one up. Alright, so first thing we wanted to do was find our profit equation, which, like I said, we did this in the 7.1 notes. I'm just going to remind you how we did it and then write down the profit equation. So remember, finding the profit is just like the single variable case. It's the revenue function minus the cost. Make sure you're careful with the cost. Distribute that negative. And when we found this earlier, it came out to negative 4x squared minus 3y squared plus 6 times xy minus 2x plus 6y plus 12. Which again I have to remember, so reading the problem, the x value represents thousands of the $18 t-shirts, y represents thousands of the $25 t-shirts. Everything is in thousands, alright? Revenue is in thousands, cost is in thousands, which means profit will also be. So I've got to remember that when I write my final answers, it's all in thousands. Every single thing is in thousands. Thousands of items, thousands of dollars. So keep that in mind when I solve this and write my answers with appropriate units. Alright, use a method of calculus to find the total number of each type of shirt they need to sell in order to optimize profit. Alright, which means go through the process that we went in the previous, the method of calculus, which means find my critical values, which means I need to find my first derivatives and set them equal to, and can show your first derivatives properly labeled. Alright, my first derivative with respect to x is going to be negative 8x, that zeroes out, 6y minus 2, and then I'll go ahead and set it equal to 0 so you don't forget to do that. And then this first order derivative with respect to y zeroes away, negative 6y plus 6x plus 6, set it equal to 0. Alright, it is a linear case, and like I said, 90% of ours will be the linear case. We will do one example that's not a linear case, but most application problems tend to be linear, which means I can use a matrix. But in order to use a matrix, I do have to reorder these. Alright, so remember, linear case, I need to put them in the form ax plus by equals my constant. And so in the first one, I need to add the 2 and move it to the other side. And so I get negative 8x plus 6y equals positive 2. And then the other one, I need to move that 6 over and reorder 6x first, negative 6y equals a negative 6x. Alright, now I'm ready to put it in my matrix and show what you type into the calculator. Alright, we're going to type this in. Row reduce. Alright, and so this is the work we want to see. Alright, so that we know how you're solving this. Alright, so this is what you're going to type into your calculator. Do the row reduced echelon form, and then it should simplify out to the matrix. Again, show this, as we know that's where you're getting your work from. Alright, so my x value is 2, my y value is 3, and so there's my critical point. And so remember, when we write our answer, we've got to remember the units. X represents thousands, and y represents thousands. Alright, so x is 2, but remember it's 2,000, and this is the x value. So either write out the word 2,000, or in this y term, I'll write out the other way. You can write out and actually multiply by 1,000, 3,000 if you want to. Either one of those forms will be fine. You can either say 2,000 in words or multiply by 1,000 and write out there. So they need to tell 2,000 of the $18 shirts 3,000 of the $25 shirts in order to maximize profit. And then to find the maximum profit, we're going to plug our 2 and our 3 into our original function. So again, just make sure you're careful when you plug it in. Alright, and again, this is also in thousands of dollars. Alright, so it comes out 19, but remember it's 19,000, or I'll probably just write it $. Oops, maybe 19, and then again multiply it out by 1,000. So that's their maximum profit. And then again, just like with the one variable case, we always want to verify that your answer does give us our maximum profit that we said it does. All right, this is sort of the check step. All right, did we actually find the optimum value? And so remember, the D formula is first. It's the second derivative with respect to x times the second derivative with respect to y, mixed derivatives squared. And with the linear cases, those will always come out numbers. All right, so I'm going to go find them. So I'm going to go back up to my derivatives. All right, so my derivative with respect to x first. So I'm taking its derivative with respect to x again. So I get the number -8, what's in front of my x term. So this is -8. With respect to y, so I'm looking at the y one now, twice. All right, so the y term, that comes out -6. And then the mixed, you can look at either one. All right, you take the mixed derivative, you should get a +6 out. Alright, so again, with the linear case, the second order derivatives always come out numbers, constants. And then you simplify it, and you should get positive values. So it should multiply out, and it does. It multiplies out to a +12, which again, that's just the check. Yep. It's an extrema. Then you have to check to make sure it's the right extreme. It turns the right way, so you write down one of your second derivatives, either with respect to x twice or y twice. X is again just the standard way we do it. That was -8, right? That was this one. That came out negative, which meant it was concave down. If it's concave down, yes, it's a maximum. Alright, so those are the two checks. Alright, we want to see this. And that's your explanation. Alright, not the last one, the next one. Alright, isn't quite the last one yet. We have 2 more. Alright. So, we look at a company that's making 2 different kinds of energy bars, a chocolate chip flavored and a peanut butter flavored. X is the price. S is the price in dollars. Y is the price of the peanut butter in dollars. Here's my profit equation that we want to optimize. Determine the selling price. Show all work and correct units for your final answer. Find the maximum profit. Verify using a d-test. Be sure to interpret. Alright, so this is sort of asking it all in once. Show your work, clearly label your partial derivative, gives your final solution in the space provided. So oftentimes this is how they'll word it on a test or a final. Alright, it'll kind of put everything together and then you do your work down here. And again, we're looking for your work. We want to see every part because the work is just as important as getting to the right answer. Alright, make it clear and label it and do it in the right order. Alright, so the first step, find your partial derivatives. Alright, partial derivative with respect to x, partial derivative with respect to y. Alright, so the partial derivative with respect to x, -1200 x, zeroes out, +1200 y, -300. Go ahead, set it equal to 0 so you don't forget. Alright, there's my first order derivative with respect to x. Now with respect to y, -2400 y plus 1200 x plus 4500 equals 0. Alright, it is the linear case, which means I can use a matrix. If it's the linear case, the first step we do is rewrite it in standard form. Ax plus by equals c, which usually means moving over your constant. Alright, so in the first one, I've got to add 300 to the other side. I'm going to write it down here. So 1200x, -1200x plus +1200y equals +300. Second one, I've got to move the 4500 to the other side, so subtract it. All right, and then I will have to rearrange my x and y. Make sure you do that. It's really easy to not do that. And when you plug it in your matrix, you'll plug it in backwards. So make sure you're careful. Rearrange it, the x term first, which is our positive 1200. Then the y term, the negative 2400, equals the constant, which is negative 4500. All right, plug it into your matrix, and again, just make sure you're careful with your negatives and your positives. All right, and then show your results. All right, this is the work we're looking for. When it reduces down to 3.25 and 3.5. All right, so there's my x value, there's my y value. Alright, so I have the answer to A. A is profit is maximized when they set the price of the chocolate chip flavor. That was the X value, and it was in dollars. So when they set the chocolate chip flavored energy bar at a price of $3.25, the peanut butter brownie was the Y, and we set that one at a slightly higher price, $3.50. Profit is maximized. We'll have to plug those into the original profit function. Alright, so again, you go back to the original one in the problem and plug those in. Alright, and I'm not going to write that step out. I'm assuming you guys can do that. I'm just going to give it, double check me, make sure I plugged it in mine right. Alright, I get, it's in dollars, 10,125 is the optimum profit. Alright, now verification with d-test and explain. Alright, so the d-test, remember, is the second derivative with respect to x times the second derivative with respect to y minus the mixed derivative squared, which again, in the linear case, these will just be numbers that we will multiply out. Alright, so the second derivative. So I go look at my x first. So looking here, taking its derivative with respect to x is going to give me a negative 1200. Second derivative with respect to y, so I'm looking on the y one, taking its derivative with respect to y, negative 2400. And then the mixed one, you can find either mixed one, you should get the same answer. Alright, the mixed derivative, so I'm going to look at x since that's the one we set it up. Take its derivative with respect to y, well that comes out a positive 1200. Alright, multiply it out. Again, it should come to a single numerical value, but do multiply it out. Alright, this one's a fairly big number. It comes out, alright, which is obviously a big positive number, so that's just check. Yes, it's an extrema. Alright, then we check our second derivative with respect to x, which was negative 1200, which is less than 0. Yes, it's concave down, which checks that it's a maximum. Right, that's the explanation part. Yes, the d-test is telling me it's an extrema. This is telling me it's concave down, which means the only shape possible is a maximum. Alright, the last example. So this last example is a case where you can't use the matrix. Alright, so in this example, we're going to find that you cannot use a matrix to solve, and so either the substitution method will be used, or it'll be the case where I only have x values in one and y values in the other. Alright, so a company, it's called Spaceflight, is offering trips to orbit around the Earth. The company will charge two different prices, a lower price for U.S. citizens. Alright, the company estimates the yearly profit will be given by the function p of xy. Right, where x represents the U.S. citizens, y represents the number of foreigners, right, projected to take the trip. A, determine the number of U.S. citizens. Alright, and again, it's sort of in order. The first one we'll do is A, then we'll do the d-test, alright, then we'll find the maximum profit. Alright, so A first, determine the number of U.S. foreigners that will be needed to take the trip to maximize our profit. So, alright, find our critical values, which means find my first order derivatives and set them equal to 0. Alright, so first order derivative with respect to x is going to be a negative 3x squared plus 480x plus 5100. Set it equal to 0 so you don't forget. So this is going to be the case where I only have x terms, right? There's only x terms in this. And I think when I take the derivative with respect to y, there's only going to be y terms in it. Right? These are the only y terms. So I get negative 4y plus 176, and again, set it equal to 0 so you don't forget. And so this is going to be just solve them each individually, right? Solve the x for the x value, solve the y for the y values. I'm going to start with the y term since it's the easier case. Solve for my y, well, I'm going to move my 4y to the other side. And so I get 176 equals 4y, divide by my 4. Alright, so y equals 44. Right, this one's going to take a little more work. It's quadratic. There's different ways you can solve the quadratic. You can solve it using the quadratic formula if you need to. You can solve it by graphing it and finding its zeros. Or factoring it. We do try to write ones that factor, at least in these types of problems, where they're not like bonus problems. Alright, so factoring out my negative 3 first, dividing out negative 3, so I get an x squared minus 160 minus 1700. Alright, and then that does factor further. Alright, I'm going to do the guess check method. You can use the box method or whatever method that you prefer, AC. There's different ways to do this. I personally like the guess check. Right, numbers that multiply to negative 1700, when I add them, they add to negative 160. Alright, well, negative 170 and 10 is my guess. If I take 10 times 170, I get 1700. And when I take a negative 170 and add 10, I get my negative 160. Alright, so I do get two answers. I get one x value is at positive 170, one x value is at negative 10. Now remember what this application means. X represents the number of U.S. citizens. I can't have negative people, and so the only answer that makes sense in the application is 170. Alright, so remember x is the U.S. citizens, y is the foreigners, so profit is maximized when they have 170 U.S. passengers and 44 foreign passengers. Alright, now give the D test. Alright, so this one's going to be a little more complex, and actually mine aren't quite spread out. I'm going to write them over here. So P sub xx first, then P sub yy, and then my mixed derivative. Alright, so with respect to x first, I go back up here. Here's my x. And so when I take the derivative with respect to x, I'm going to get a negative 6x plus 480. Alright, negative 6x plus 480. Alright, when I take my derivative with respect to y twice, so I'm looking at the y1, so here. With respect to y, well, that's just going to leave me with negative 4. And then the mixed one, you can look at either one, right? If I take the derivative of either one with respect to the other variable, well, it zeroes out, right? If I take the derivative of this with respect to y, there's no y, it zeroes out. Or if I take the derivative with this with respect to x, there's no x, so it zeroes out. So the mixed derivative is just 0. Alright, write the D formula. This time it is a formula because I will have x terms. Alright, it's the derivative with respect to x, so the negative 6x plus 480 times negative 4 minus 0 squared. And so if we simplify that, I'm going to multiply through by my negative 4. So I get positive 24x. Oh, that should have been a squared. I missed my squared there, right? If I go look at my... Well, not squared. Alright, I had it right. Don't doubt yourself. Go with your first instinct. Alright. 24x minus 1920, and then the 0 zeroes out. Then I do have to plug in my point. My point was 170 for x, which that's really the only one I need. 44 for y. I've got to plug my 170 in. Alright, when you simplify that, it comes out to positive 190. Should come out positive, but I'm going to double check that it does. The number I have written down, I'm going to double check it. So 24 times my 170 minus 1920 comes out positive 2,160, which is greater than 0. All right, remember, that's just the first step. That just checks that, yes, it's an extrema. All right, then I have to check my second derivative with respect to x or with respect to y. Now, if I just looked at y, it would be the easier case. That came out negative. But since the problem does say, since we do set it up, I will do it in the case with the xx, just so that you know how it works if we've got a variable. And so my second derivative with respect to x was negative 6x plus 48. I plug in the x value at my critical point. So we're going to plug in our 170 for x. And so when I do that, it should come out a negative number when we do. So we take our 170 times our negative 6, add the 480, and it comes out negative 540. Alright, which means it's turning the way I want it to, right? And that means it's concave down. So yes, it's a maximum. You can read that. Yes, it's a maximum. Alright, so concave down, yes, it's a maximum. D-test said yes, it's an extrema. Alright, so that would be the d-test with the explanation. And then the last thing is to find the maximum profit. Alright, so you go back to the original profit function, plug in your 170 for x, your 44 for y, and again, it's going to come out $. So again, you go back and plug it into this original function when we're finding r. So again, just make sure you're careful when you plug it in. I do believe it comes out to a fairly large number. So again, when we plug it into the original equation, 170 for x, 44 for y, right? X is 170, y is 44. Alright, double check me on this. Alright, I get that it comes out to be almost 2,199,382 is my maximum profit. Alright, we will stop there. Again, make sure that you look this over. This will be something like this on the test, and usually there's something like this on the final. Again, we're just as interested in as the right answers as the show your work. So showing your work in these cases are important, which means show your key steps, show that you found the first order derivatives, show the algebra that you solved for them correctly. Alright, write the answers down with correct units, show your second order derivatives, the d-test, with a simple what it's telling you, right? Just like we did with the one variable case, you're getting numbers out of the d-test, you're checking things, you're checking them for what reasons, alright? So again, when you solve these, that's what we're looking for. Alright, so that finishes up 7.3. Alright, we skipped 7.4, so there's only one more section in chapter 7. We're going to get to 7.5, which are more optimizations, but they're a special case. Alright, a special type of optimization that we have to use a special process to solve. Alright, so we're skipping ahead to 7.5 as the next set of notes. We don't cover 7.4, and that's the last set for this chapter. Alright, we're going to wrap up this video here and pick it up in 7.5.